Thanks for joining us today. My name is Ralph Lopez, and I'm the Deputy Director here at the Carnegie Mellon Institute for Strategy and Technology, specifically responsible for security policy studies. For those of you just visiting, this is the Scientist and Strategist Speaker Series, one of our keynote programs here at CMIST. Here we produce groundbreaking research, we inform key policy decisions, and equip current and future leaders with the skills to navigate the evolving landscape of new technology, security, and international affairs. With three interconnected pillars, academics, thought leadership, and the Washington Center, CMIST operates as a team of teams across the university. Our collaborators include every college and every institute, with key focus on partners like SciLab and the Department of Engineering and Public Policy. While CMIST's academic and teaching expertise is part of the Dietrich College of Humanities and Social Sciences, we are an interdisciplinary institute that work across Carnegie Mellon University to tackle the risks and benefits of emerging technologies in war and peace. This is why Scientists and Strategists series focus on the space between the development of advanced technology and national security, with the intent of informing both the strategic and policy implications of those actions. Here to provide the introduction of our guest speaker is Professor Baruch Fischoff. Baruch's place in CMU history is tremendous, having begun his career here in 1987. He is the Howard Hines University professor with a placement both here at the Carnegie Mellon Institute for Strategy and Technology and the Department of Engineering and Public Policy. With a background in mathematics and psychology, he earned his PhD in psychology from Hebrew University in Jerusalem. A distinguished expert in decision and risk analysis, Baruch is a member of the National Academy of Sciences and the National Academy of Medicine. His expertise bridges academia, policy, practice, making him a vital contributor to understanding and addressing complex societal challenges. He's a perfect spokesman for CMIST and our Scientists and Strategists presentation. Thanks for being here with us, and thanks for introducing today's speaker.
You think I could find the switch. So thank you, Ralph, and thank you, Audrey and Abby and Rosalie and everybody else who made this possible. So it's really a great pleasure to introduce Sam Weiss Evans. He did his undergraduate work at St. Olaf College and his graduate work at Oxford. He's had really interesting research positions at Harvard and elsewhere, and is now a senior staff person at this National Security Commission on Emerging Biotechnology, which I have to admit I had not heard of before Sam came here. I spent much of today reading their website, which I strongly recommend to you. I kept reading it and thinking about, wow, I'm glad somebody's worrying about that for various things that I've dabbled in. So I thought what I might do to give you a feeling for the complexity of these issues, to mention three things that had come to mind. So about 10 years ago, I was asked to give a talk to the National Scientific Advisory Board on Biosecurity, which was moderating a dispute over gain-of-function research. A gain-of-function of Ebola is becoming more transmissible, looking at it from the virus's perspective. And there's some people who think we should absolutely do that, so we're a step ahead of the virus, and other people who think, no, we want to go there because there may be a handful of people who can figure out the formula, and then lots of people might be able to replicate it in their basement. And there was a dispute there over whether this was primarily a biosafety problem, getting it out of the lab, or a biosecurity problem of somebody capturing this and then weaponizing it. And for whatever reason, this was defined as a biosafety problem. There were people from the Department of Homeland Security kept getting up and saying, but. And we just didn't have a mechanism for dealing with that. A second example was our colleague Erica Fuchs last year ran a national network for critical technology assessment, which was in effect meant to give our country a technology policy. And one of the areas that they were dealing with that I had, we had 4 areas and then 4 methodologies. So I dealt with the public acceptance methodology, and we focused on biotechnology. And I didn't realize that there are 320 drugs currently with shortages. And it turns out it's a function of market sources with generic drugs. There's maybe one place that produces one ingredient for everybody. So the commission is working on that as well. And third example, I'm currently a member of the biocontainment CDC's polio biocontainment working group. And they asked me to join. My wife and my mother both had polio. I thought it was not a big problem, but I have some commitment to polio. Well, it turns out there's not a lot of polio in the wild, but there are 800 labs around the world that have polio virus. The criterion, as far as I can tell, there's no particular criterion for being polio virus. I don't know. They've got some bureaucratic name for it. And so imagine trying to come up with an international standard for keeping this polio where it is. As far as I can tell, the best thing that they can do is to make the licensing sufficiently expensive that people who don't really need the virus will give it up, because people who just have the virus don't want to, maybe we'll be able to do something with it one day. So these are 3 very different areas. And this commission it seems to be dealing with all of it, and I'm really looking forward to hearing what this and more, to hearing what Sam has to say.
Okay, thanks very much, Burke. Thank you to Audrey and the whole team at CMIST for the invitation for this lecture. It's really a treat to be able to take a moment after 6 months, basically, in the policy world. So I'm still fresh there, to come back and remember a lot of the academics that I'm basing my current work on. But a couple of just points at the beginning. This isn't going to be a talk about the commission. I'm very happy to talk to you about the commission and its work, but I'm here in my personal capacity today. So I don't represent the views of the commission or the work of the commission in today's conversation. However, what is happening is that this work that I'm presenting today forms the basis for the work that I'm engaged in at the commission personally. And so your thoughts and ideas on how this is spilling out are immensely helpful to me in all of my capacities. Okay, I'm fascinated by things that don't fit into categories and the work that categories do for us. All of the categorization work we do individually and as a society, from this is a bottle to we are a family, helps us to make sense of our world while at the same time constructing that work in meaningful ways. In other words, categories matter. Who gets to make them and in what ways can have significant repercussions. Just consider statements like, you don't belong here, or this is a weapon. In policy, we often govern as if the world fits neatly into the categories that we build. This is a tank. You are a foreign national. But obviously it isn't always this clear. When we don't anticipate how our categories are inadequate for the work that we're meant to do, we get events like 9/11. So those of you above, I don't know, it changes so quickly now, 30, probably have an understanding of like where you were in 9/11. I was raising the flag on the flagpole outside of the Student Center at St. Olaf. Somebody's like, oh, you might want to put that at half-mast. And I was like, why? Went inside, saw the second tower fall in real time. And then I watched. I spent the whole day watching on campus. Like, this is my reaction. I was like, I am so fascinated by the fact that nobody on campus has any idea what to do, and they're worried that St. Olaf will be next. We're a small liberal arts college in the middle of the cornfields of Minnesota, right? And I was like, this is weird. Like, what's going on here? there is a substantial change in people's, like, the thin veneer of security that people have because of this little categorization shift that just happened. Well, I've spent much of my life since exploring the landscape of things of anomalous or ambiguous security concern. How do states and others govern this space? How do we even understand what the space is? And how does our understanding tied to what we do about it? Over the next 40 minutes or so, I'm going to walk through some of the dominant ways that we've carved up this landscape and its limitations and some thoughts on alternatives. But first, the current system that we've got is largely based on these two words. Though confusingly, there are multiple concepts tied to them. So let's start with getting a sense from the room about what you think the term dual use means. What's it mean to you? What comes to mind? No wrong answers. No right answers probably either. But yeah, go for it. Civilian and military. Okay, that's a good divide. Yeah. Is there another way? Yeah.
Drug that can be used either. I mean, that's off-label use.
An off-label use. Okay, so nothing really necessarily related to security. Okay. Yeah. Go for it.
A platform that could be used for positive change or present some sort of security issue.
Okay. Yeah. So you've got this kind of security issue, but it's ambiguously defined. It's not strongly like a military issue, but more ambiguous security. Anything else? Any others? Yeah.
Probably any sufficient in general for this technology.
Okay, but what's the duality? Like, how are you carving up the concern?
Yeah, I guess like something useful enough to be worth caring about.
Okay, so interesting. I don't think that you're talking about this term. Do you think that you are?
Yeah, they mentioned it now.
See, this is interesting, right? Okay, so what's going on here, right? So dual use, like, there are a couple of problems with this term, right? But let's just talk with dual and with the use. So dual, like, there is a binary world that this exists in, right? And by calling it a dual, you are automatically prescribing the binariness of that world. And the use, you're focusing on what's going to happen with this thing, not how it was built, or like who was involved with that, or any of the other ways that this thing might interact with the world, right? The point is that, well, first of all, there are histories tied to this kind of term and this way of understanding this ambiguous, anomalous way of identifying security concerns. And those histories are embedded in the political and organizational ways of governing the security concerns that they identify. Okay, so I'm going to tell a couple of stories about how the categorizations that we govern this space are, where they came from. And after walking through stories, I am going to argue that in areas of emerging technology, there's a value in understanding these initial moments of categorization. So I'm interested in like the process to generate the understanding of how we carve up these categories of things that we're concerned about and things that we aren't. And then I'm going to talk about the consequences of those categories. What are the intended and unintended consequences, and also the difference between the idea of governing these things and what happens in practice. And then I'm going to talk about some of the experiments in security governance that we might want to be pursuing more to think and build differently. Okay, so this first story is actually a series of moments all tied to the development of our modern export control system. The second story covers one moment in particular around the export control debate where a line was drawn between national security and academic freedom. And the third is a set of negotiations at the beginning of the genetic engineering age that carved out biological research that could and could not be related to weapons of mass destruction. Okay, export controls. It's said that the export control system today is second only in complexity to the tax code. It's a vast system to monitor and control the flow of knowledge, goods, and technology between nation states. And it all rests on lists. Today, these lists are divided into two main categories, the munitions lists and dual-use goods and technologies. And the lists are harmonized internationally through 4 multilateral voluntary regimes. One of these, the Wassenaar Arrangement, was, at least until the Ukraine war, the site of a vast majority of negotiations. This is the arrangement that covers the conventional arms and dual-use goods and technologies, so non-WMD related stuff. I spent my doctorate studying the Wassenaar Arrangement's dual-use list modification process, and I'm happy to talk about that as long as you want to listen. But where did these lists come from? Any guesses where export control lists came from? Military, yeah, okay, all right. Well, the answer depends on how far up the design process you actually want to go. Where do they come from? You can talk about specific list modifications. How do we craft the language for controlling quantum encryption, right? You can talk about the cleaning out of categories. So this is what happened with the Export Control Reform Act and the kind of let's start with clean categories and like add items back to those lists as a way of modernizing the export control system. You can talk about the realignment of categories that happened in the 1990s when the Cold War export harmonization process, COCOM, the Coordinating Committee for Multilateral Export Controls, went through the process of the new form to turn into the Wassenaar Arrangement. And this was like not just cleaning out the categories, but like ostensibly starting afresh. And then this is a movement from like an industrial list to a dual use list. So there is a change that happens there. Yeah, okay, all right. You could talk about, we could go back further though. We could head back to the formation of the modern export control system, which was really at the end of World War II, during World War II, and then the end it was codified internationally with the establishment of COCOM. Heading all this way back is helpful because it shows that seemingly highly technical decisions, like the definition of quantum cryptography, are part of a much bigger set of decisions around the political order of modernity. The negotiations around the establishment of COCOM in the period between 1945 and 50 were inseparable from the rebuilding of Europe, the codification of the US as the dominant world power, the concern from the West of the rise of the Soviet Union, and the battle of the underlying commitments of liberal democracy against communism. But we haven't gone back far enough yet. The export control system itself doesn't rely on the political structure of the state that implements it, at least at a very high level. The Wassenaar Arrangement, for example, was founded on the belief that Russia was an essential partner in ensuring that a global export control system was an effective tool at ensuring security, or in its words, quote, preventing destabilizing accumulations of conventional arms and dual-use goods and technologies. The roots, though, of this process go much deeper into the relationship between the concept of the state, science, technology, and security. The lists that were used at the start of COCOM were not created from whole cloth. They were a result of lists drawn up during World War II. These lists were taken from a governance system that had all but collapsed by that point, the system of contraband and its reliance on prize courts. This system, in turn, came into being with the rise of the global trading empires of the 17th century and the need to ensure the freedom of trade while states were at war. There's a very real line to be drawn then between our modern conception of export controls and the information and the formation of the concept of a nation state. Why does this matter? It matters because it shows both how ingrained this type of thinking is, and the thinking, just to spell it out here, you need to enumerate the objects of security concern before you govern them. And that controlling the trade is the thing that will ensure your security. But equally, the security is as much economic security as it is military security. A lot of the contraband negotiations were around ensuring the neutral states to a war were still able to trade. Okay, part 2 here. Another way to decide. Wait, hang on. Let me make sure I made my point clear here. Yeah. Yeah, so it's basically balancing market concerns and military concerns as a security matter. Another way to decide that the tools of another way of understanding security concerns and how to manage this ambiguous, anomalous space is to decide that the tools of security governance are so ham-handed that they are likely to upset the whole apple cart upon which the prosperity of the state is based. Export controls have always attended to the transfer of intangible technology, i.e. knowledge, as well as tangible goods. I don't know if anybody here knows Mario Daniels and John Kriege, but they just produced a new book called Knowledge Regulation and National Security in Post-War America that really does a fantastic job at spelling out this history in a lot of detail. It was the book that was written, and I was so glad when I read it because I didn't have to write that book then to make the points that I needed to make. So this understanding of export controls, controlling intangible technology has a long history, but the tensions between universities and the security establishment in the U.S. have also had a long history. And the particular way that the categories of security concern were made would have significant consequences for how we're able to govern today. So if we think back to the 1970s, there were a couple of moments that are of key importance for understanding this, this area of the carving up of these categories. In 1976, the Defense Department produced a report, the Defense Science Board produced a report called the Boosie Report. It's on analysis of export controls of U.S. technology, DoD perspective. And they basically made a hard line to say that a lot of intangible technology and research universities should be subject to export controls. We should follow the line all the way back from the actual militarily useful widget to like the knowledge that's needed to produce it and the next generation of it. This was coupled with a lot of visa control issues around scientists being able to come and present at conferences. Vacuum tube manufacturers had a big blow up over this issue, and a couple of bodies were convened to try and address these concerns. The National Academy of Science, Engineering, and Medicine produced a report often called the Corson Report on scientific communication and national security in 1982, which was which forcefully made the argument that academic freedom was essential to national security. But this report also allowed for a gray zone between the research that's clearly not of concern and research that and research that might warrant some controls. So how did Corson divide up this gray zone? This is really interesting because there was a lot of pushback, both from the intelligence community and from academics on this gray zone formulation. So they gave 4 conditions. 1, that the technology is developing rapidly and the time for basic science to application is short. 2, that the technology has identifiable direct military applications or it is dual use. What technology isn't dual use, or what knowledge isn't dual use, right? And involves process or production related techniques. 3rd, the transfer of the technology would give the Soviet Union a significant near-term military benefit. And finally, that the US is the only source of information about the technology, and therefore warranting some kind of control locally. So they said that if the technology, if the gray zone area satisfies these criteria, then what do? Then the government should be allowed to restrict foreign nationals. Then the government should be allowed to review publications, not stop them, but have a 60-day window to review them. And importantly, they said this shouldn't involve any kind of export control related issue. Well, rather than quelling the debate, this report made it hotter. And then the government tried to do something else about this, and that also failed. It was when Reagan signed the National Security Study Directive 1482 at the end of 1982, entitled Scientific Communication and National Security. It set up an interagency panel at OSTP, and that group produced was supposed to produce a report in a year. They did not produce it after a year and a half, and it was widely understood that this body was basically dead. So what do we do? There was another effort, though. In 1981, the U.S. House of Representatives Committee on Armed Services requested the Undersecretary of Defense for Research and Engineering to constitute a task force to investigate the responsiveness of American universities to national security requirements. This task force recommended the creation of an entity called, well, it was an entity called the DoD University Forum, which was to create a forum to allow for periodic consultations between senior university representatives and DoD officials on the full range of research-related needs and issues that affected the department's ties to universities. So the interesting thing about this forum, though, is that it had this very split structure, right? So DoD and the AAU, the American Association of Universities, were both co-chairs. Their administration was split, their funding was split, the meetings were held alternately at one spot and then the other. In its first annual report, they noted that the observers of the university government interactions noted that the evolution of the forum, along with the way it operates, is unique in the federal sector. Everyone, it appeared, seemed a bit surprised to learn what happens when groups with significantly different views of how to identify and then govern security concerns in science were given the time, space, and resources to find a common path forward. Quote, rather than being awkward, this arrangement has worked well, has enhanced the operation of the forum, and contributed to the cooperative spirit which has underpinned deliberations between DoD and the academic community to date. So they formed a working group to deal with this issue of what to do on how to carve up this category. And it was this working group that largely led to NSDD 189, the National Policy on the Transfer of Scientific, Technical, and Engineering Information. This policy is a red line document. So it's like, or rather, it's like a line in the sand. So it says, whereas a list carves up the idea of dual use in many, many different ways, this is one way. And that one way is the definition of fundamental research. So fundamental research is a term that they created for this document, and it means basic and applied research on the life sciences and engineering, the results of which ordinarily are published and shared broadly within the academic community, as distinguished from proprietary research and from industrial development, design, production, and product utilization, the results of which are ordinarily restricted for proprietary and national security reasons. And then the policy was, to the maximum extent possible, the products of fundamental research remain unrestricted. And if you're going to control it, the only tool that you've got in the box is classification. Okay, so this is very different, right? This is not lots of variation, lots of gray. This is not what the Corson report was recommending. This is, no, there's a clean cut here. And that was done to protect academic freedom. And this understanding that science is done apart from society, and so get the security out of the way, and then we're gonna deal with we'll deal with that later. But right now, you have to allow the freedom of research. These two ways of crafting security concerns jointly came into play with the ways that the U.S. has categorized and governed security concerns in genetic engineering and its modern-day equivalents, synthetic biology or bioengineering. All right, so what went on with bio? So now we're still kind of in the 70s period. And Nixon ended the U.S. offensive biological weapons program in 1969. That's right, yeah. And the Biological Weapons Convention at the United Nations was concluded in 1972. And by the mid-1970s, when genetic engineers started being concerned about government action on their work, and about the potential harms that may come from it, they convened a set of meetings. There were some in Cambridge, but the more famous ones were out in Asilomar, a small conference venue out in California. There are a couple of interesting things about this meeting. Who was in the room and who wasn't in the room is important, right? A bunch of scientists, a couple of reporters, more lawyers than you would expect. And the scientists were genetic engineering, molecular biology kind of people. Who wasn't in the room, right? Environmental, ecosystem kind of types of researchers. Anybody who might be affected by any of this research. The military, right? David Baltimore opens the meeting. And this is a quote from his opening message. Second, an issue which I think is very serious and which many of us have cared for a long time about, which is the potentiality to utilize this technology for biological warfare. And again, although I think it is obvious that this technology is possibly the most potent technology for biological warfare, this meeting's not designed to deal with that question. Right? So what's off the table? Any kind of ethics question, any biological weapons, and therefore any kind of security conversations, any environmental conversations. If you think about where are the big problems in biological research today, those are all the issues that are not on the table at this meeting. What they did is they crafted the conversation so that they could govern themselves, which meant that the topics of the meetings had to be stuff that was related to what the scientists were experts on. Therefore, this became a meeting about biosafety, and the idea that what is needed is for the scientists to not stick themselves with needles, to have a biosafety laboratory level system where you understand with different risk groups of organisms what kinds of adequate protection are needed. So the BSL system came out of these sets of meetings. The Institutional Biosafety Committee, this idea that you needed a committee kind of check on whether you were actually maintaining these rules, came out of these sets of meetings. The Recombinant Advisory Committee that for a while checked every research program at a federal level to ensure that they weren't going over the line, came out of this meeting. And it's not just political and organizational structures. E. coli K12, like the decision to focus on E. coli and not yeast as the main pathways for research and to create an attenuated version of E. coli that everybody could work on. That's had massive ramifications for how biological research has proceeded to date. Came out of this meeting. That's a really big result of carving up here. And it was done largely to ensure academic freedom. There will be consequences. These systems don't always work the way that we expect them to, and they have consequences that we don't anticipate, but we could anticipate them. They're unintended consequences, but they're not unanticipatable if you're asking the right kinds of questions. The problem is that we haven't been asking the right kinds of questions. So what do we get? How is the Asilomar model, this model that came out of those meetings, not actually hurting us today? So first off is that the ways that the biosafety system has evolved, it's evolved as a set of lists of things that you need to be worried about, things that you can and can't work on, like the select agent list. If you are working on these things, if you're working on a select agent list, then you're at a biosafety level 4 lab. You have more people than just a biosafety officer, and you get like all kinds of oversight. You've got check-ins from the government. You can go to jail. You can, all kinds of issues come into play here. And if you're not, that's the amount of attention you get to security concerns. And so security and safety are seen as a compliance issue and not a zone of curiosity, not a zone of, like, if we think about this a little bit, maybe we actually can do better research. Security issues are often cast as safety issues, and I'll go in more to that in a minute. Scientists don't think of people with security expertise as actually part of the research process. They think of them as the hoops to be jumped through to do the things that they want to do, but not as, maybe you can help me think of what a good idea is. Okay, so I'm going a little long here, so I am going to speed things up a little bit and just say that the way that this ends up working in practice, and sorry, this is both too small and horribly color-coded. So I'm going to walk you through it. So you start over here with this idea that all research is dual use, right? And this is where, of course, this is where the Fink report in 2004 on biological research in an age of terrorism opens. It's like all research is dual use. Okay, cool. All right, that I can get behind that as a starting point. But there are two pathways that you can take here. You can say, okay, all research is dual use, and therefore, we don't know which research poses security concerns. So we need to create an ability for the system to adaptively and periodically assess, is this too concerning or is this not? Or we can say, we only need to be concerned about a small amount of that research, and that's what we're going to focus on. Guess which one we chose, right? Oh, it's like, oh, wait, hang on. We've got these lists from export controls. And we've got this set of experiments of concern that the Fink report in 2004 published. Let's wrap those up. We're going to call those dual use research of concern. So here comes the dual use language back in again. And we're going to put in a whole process of oversight for that. The problem is that you've just created another compliance system. And so if we know it's concerning, then we have this whole process in place. If we don't know what's concerning from a security perspective, we have no training and capabilities and organizational structures to actually work through how we become concerned and how concerned should we be, right? We're not training researchers to be security curious. We're not experimenting with different ways of understanding and governing security concerns. What we end up with is instead a governance system that is bifurcated, that says, because you are working on security work, or because you're working on a select agent, then you have all of this oversight. And if you're not, you have none of it. The system itself is problematic, and that's come out time and again through academy studies, but many others. An over-reliance on select agents is a systematic weakness affecting many states, or many aspects of the U.S. biodefense mitigation capability. The dual-use research, development of dual-use research concern policies is simultaneously too broad and too narrow. Right? This doesn't, and when these policies got developed, there was this whole series of events. This is often how policymaking works. There's a series of key events, and then everybody's like, oh my God, we got to do something. And then they do something. But systematically, the things that we've done in biosecurity do not end up, the policies that we end up putting in place wouldn't have caught the stuff that raised the concerns in the first place. Anthrax, the mouse pox papers in the early 2000s, the creation of a novel bacteriophage, none of this stuff, which all spurred a lot of attention to biosecurity in the early 2000s, would have been captured under dual-use research and concern policies. Training, as a result, gets bifurcated too, right? So I don't know, how many people had a science training? How many people had a social science training? Humanities? Oh, interesting. Okay, all right. So I don't have any time for this. I'm going to say this very quickly. So my last job, part of my job, was reforming the undergraduate curriculum in the School of Engineering at Harvard for attending to the broader social aspects. So I had to figure out how to work with all of the existing courses and weave a thread through that made the students more conscious of and aware of not just the security, but the ethical and all of the other broader aspects of the work that they were doing. What did I have to start with? The students were given a 1-hour compulsory lecture that the lecturer didn't want to give, the students didn't want to be at, and this was made very clear at the beginning, and it was on the Space Shuttle Challenger decision to launch, which is a block template that they buy every year, the rights to be able to give this lecture, and then they just kind of run through it in a rote process, right? That's what I had to start with, because that is the incentive structure within our current system of training scientists and engineers to think about these broader aspects. That's as far as it goes at a mid-rate university like Harvard. Right? Okay. So, what do we do? What's the problem? Yeah, I made this hard to read on purpose. I've tried several methods of attending to the concerns and thinking through. So these systems are so ingrained. Some of the ways of understanding how to create a security governance system go back to the formation of the concept of a nation state. How are we going to change the system? What do we need? What do we need to change? It's not good enough to just call from academia that this system needs to change. We've been doing that for decades in science and technology studies and in other areas without much movement. The institutions themselves have so much momentum that they are not willing to change, I think, unless they can see how it can be done otherwise. So let's show them how it can be done otherwise. That's the basic idea behind experimentation in security governance. And so I got a bunch of people together in 2019 in Cambridge. We went punting, Cambridge, UK, not Cambridge, US. We went punting. We worked up this paper in science on embrace experimentation in biosecurity governance that had these basic tenets. That we should be building a capacity to think differently, and that capacity needs to be grounded in a system of testing out an alternative governance system and documenting that test, and then analyzing, learning, and sharing that test. So first we needed a kind of baseline. What's actually being done? So my close colleague and friend Megan Palmer and I ran this 3-year initiative with funding from NTI Bio. Megan was at Stanford, and it's called the BioRisk. It was called the Visibility Initiative for Responsive Science. Our output was the BioRisk Management Casebook. This, for really the first time, we interviewed 130 different organizations, and most of them are all off the record, collecting data across the research life cycle on how do you actually think about this weird, ambiguous area between the stuff that we know we need to be concerned about and the stuff that we're not sure about, and the stuff that clearly we don't need to be concerned about. And this was an idea of saying, okay, so let's just get some empirical data from those who actually do this work. That produced a set of case studies. This is available on Stanford's website, and our team reference there. I'm happy to share the slides afterwards. So we have case studies from science, from funding organizations, from academic research outfits that show how they manage this gray zone. And in particular, what we're trying to showcase is the curiosity that they're bringing to the table, that they're thinking about not like how do we comply with the law, but how is the law not quite adequate for the kinds of concerns that we need to be dealing with, and how are we trying out stuff differently. The second effort I've been involved with for over a decade now, I help lead part of it as well, is the International Genetically Engineered Machines Competition. Who here has heard of IGEM before? Ooh, okay, all right, good. So this is a yearly competition. Right now it takes about 6,000 students a year from about 40 countries around the world. And the students are given a task to build something new with biology. And over the course of the last decade, we have moved attention to safety, security, but also what IGEM calls human practices, but it's the broader social ethical conduct, from a sideline kind of affair to being at the center of the competition. And interestingly, in this kind of body, it's largely voluntary, and the Safety and Security Committee includes biosafety, biosecurity officers, government officials, academics from all over the world. And they see this space as a space to test out new ideas on governing, right? So we were the first body that had a policy on gene drives. So the ability to purposely modify the environment. Like we came out, before, well before anybody else. And the reason why we did that is because after the first synthetic gene drive paper was published, less than 12 months later, there was a team trying to build a gene drive. That's how quickly this kind of space is moving. And so we had to have a policy on what do we do in this case. We create those as adaptive and reflexive policies. So it's a yearly cycle. So we are able to make the rules. So this is a lean organization, and we can set, the worst that you can do is like you're expelled from the organization, like you're expelled from the competition. And the best you can do is like, here's a trophy. But that trophy is a really meaningful like attainment for the students that are participating in this. And so we use this as a sandbox for regulatory and governing approaches. So we're working right now on how to assess and consider the AI security and safety concerns in relation to biology. Okay, second one, I'm almost done here. So I was an advisor to DARPA on one of the programs called Safe Genes. And this program ran from about 2018 to 2023, something like that. Its head, the program manager, was Renee Wagerson, who's now the director for ARPA-H, the Advanced Research Project Agency for Health, the newest federal agency. But there was a couple of interesting things about this experiment in security governance. So one, before DARPA started funding people to build a gene drive, because that's kind of what this program was initially about, like we're going to fund a National Academies Committee. So that committee produced the report Gene Drives on the Horizon. And then they said, we're going to form an advisory group specifically for the legal, ethical, environmental, dual use, and responsible aspects of this work. They called it the leader group. That leader group is going to be formed before we put together our solicitation. Right? This is a key step, right? Because oftentimes what happens is that all of this security and other stuff is an afterthought to the funders. Right? When the Synthetic Biology Engineering Research Center got set up by NSF, they're like, okay, these great guys, Drew Indy, Jake Kiesling, whatever, these are wonderful people that want to be bringing about the age of synthetic biology. Oh, by the way, you guys have to have some kind of security work going on with this as well. They didn't even say like the ethical, legal stuff. It's like, no, security work is the stuff you have to have going on. And that afterthought structured the entire structure of SynBIRC, of the Synthetic Biology Engineering Research Center, which I was also part of for the second half of it. But this DARPA one was like, no, we're going to do that first. So they're going to be involved in the call, and that had substantial ways of altering the research that was done. So instead of just developing a gene drive, they developed detection capabilities. They developed remediation capabilities. They developed, understandings of what it means to develop a full drive system versus a localized drive, so that you can stop its spread from spreading in I should have said, basically a gene drive is you edit an organism that then you release into the environment. That organism mates with organisms in the environment. Usually half of the offspring will be edited and half won't. A gene drive will make basically all of the offspring modified. So it's a very, the idea, the promise is that it's a very easy way to spread a genetic trait throughout an entire wild population because it goes exponentially. Okay, so that might not be a good idea. So they funded this attention to the safety and security issues from the beginning. But they still had to dance with who brought you. So even with the best of intentions, this research program had to deal with researchers that weren't trained in doing this, or with teams that didn't understand how to work between the social sciences and the natural sciences and engineering. And the majority of the work then was substandard from the actual attention to these issues. Okay, so I'm going to leave you here with some tenets that I'm working on that are not set in stone by any means, and I would love for you to push back on all of them. Of how do we create a changed governance system for a changed governance mindset? So what if we start, as I showed you on that chart, from the idea that all research can be used in a manner that causes harm, right? And I'm not drawing the military-civilian line that we started with on dual use. Those harms will likely disproportionately accrue to, in effect, those already in disenfranchised communities. So oftentimes the ideas of people's initiative to say, oh yes, we should be thinking about these things, very quickly goes to, oh, but we can't involve everybody in the conversation. Therefore, and nothing gets done, right? So why don't we just start with the people that we were pretty likely, because historically they've been at the short end of the stick. Okay, so then you listen to them, but research is done should actually be attentive to the concerns of those communities, so actually have a feedback loop in. To assume that we don't know what's going to work well in terms of our governing capacity, and therefore we need to accept that it's not, policymaker A's great idea that they base their whole project on, and then it has to, it has to be that thing and not change. But it can change over time, be adaptive and learning. Then institutions that fund, conduct, or support life science research should actually be empowered to experiment with alternative approaches to identifying. So there needs to be that kind of top cover for the people on the ground who have to deal with the day-to-day governing, like the biosafety officers, for them to say, like, I know how this system doesn't work in practice. Like, you give me this list of select agents, like, we're not working on that, but we're still doing really concerning stuff. To give them the cover to say, okay, then let's play around with how we get concerned about that. And not just play around, but learn and share that learning. We have a very, very strong nerve in bioengineering to kind of hide all the stuff that doesn't work, and hide anything that might be a potential ethical or security issue, rather than saying, like, okay, we actually need to talk about this, because talking about it turns out to be really hard. But it's what's going to come back and bite us in the end. So it's these kinds of ideas these kinds of tenets that I'm bringing to my work on the Commission. Thanks for your time, and I love your questions.
That was great. Thank you. So I've got lots of comments, but
I'll stand over here.
But let me get just one comment, and then one question, then we'll turn it over. When you have that one figure where you showed there was a graph.
Bifurcation.
It really, the bifurcation really resonated to the gain of function. And other thing, one of the things about the biosafety is there's an illusion of it being analyzable, whereas the biosecurity isn't. Like most security things, you can't do a risk analysis. It's an illusion because you can't really analyze these systems, but it has this, and I think that kind of fits here. So I was wondering one of the things I was thinking about, knowing how having other experiences related to how hard it is to move these communities along their natural path, which, for good and bad reasons. I was wondering whether so one of the things that's going on in some parts of the relevant science is this One Health movement of bringing together sort of animal and human health. And I've been part of some conversations about the two labs in Wuhan. One that had a biosafety issue, other had a biosecurity issue, and I wonder whether there's something going on that that the scientific community is doing that would be a natural process that into which these concerns, the biosecurity issues could be interjected, as opposed to trying to push it into each of these communities that's busy getting these new technologies off the ground.
I think I'm going to answer this in a slightly different way, because what I hear you saying is that, like, one way to read the approach that I'm suggesting is kind of a bottom-up bubbling of new ideas. There's another component to this, though, which goes back to why I started with just throwing up the word dual use on the screen. And it's that we need a new language. We need a new language that is tied to a different vision of the relationship between science and society that undergirds this. And so, like your point about drawing on One Health is an interesting motif, because what One Health is trying to do is it's trying to say, agricultural health is not separate from human health, is not separate from these other ways of understanding health, that they're all integrated together, and our understanding of how to address health issues should be integrated as a result, right? So that is a change in this kind of categorization process, right? I started the talk talking about how we make these categories. One Health is an effort to change the category that we use to address these kinds of concerns. But does it go far enough, right? So you could say that a One Health kind of idea and ideas like it are at the root of an organization like ARPA-H, which is trying to create new capacities technical capacities for attending to health. But is ARPA-H addressing the lack of a national health service? Is ARPA-H addressing the patent structure of biomedical technologies? Like, they're not set up to address that because they think that the issue can be solved by technical means, right? Like it's a difficult problem to crack. So what I'm suggesting is that we understand these issues as inherently organizational and social and political as well as technical. And that kind of shift in understanding needs to be tied to new language and new visions about the relationship between science and society. So instead of dual use, finding other ways of talking about it, whether it's biorisk, which is not that much better, but other ways of talking about this issue. Showing that it's starting from the position that science is a thing that is intimately social, but that doesn't mean that like any knowledge, like all statements are equal, right? Like finding ways to avoid that relativism, slopism, kind of solipsism is kind of where I'm stuck right now.
Okay, thank you.
Thank you. Well, this is really interesting, Sam. And you're right at the heart of what we hope CMIST is all about. So I'm very excited by your talk. But I'd like to ask you about the incentive structure. And you've talked about military and academic, dichotomy, that bifurcation. But a big piece of the incentive structure is commercial ability to make a tremendous amount of money from the various advances in biotechnology. So how do you fit that into your model? And also, how do we avoid doing what we've done over the centuries, which is only to change these major societal structures in the aftermath of a big disaster?
Yeah. The commercialization thing. So one thing that I would say is that there was a period when we didn't commercialize on federally funded research, right? The Bayh-Dole Act changed that. And that was a moment of realigning like how we understand the relationship between science that's produced in the research universities and society, by saying, the benefits of federally funded research don't necessarily have to just be accrued to the public through that open knowledge sharing of the results of federally funded research. It can be patented. That's what Bayh-Dole gave us the ability to do. And then Diamond versus Chakrabarty, Supreme Court case, allowed the patenting of life forms as well. And so you open up all of biology to commercialization as a result of that. This kind of shift does put a huge incentive structure for the market to be shaping academic work, but it's not talked about that way within academia, right? It depends on who you talk to, but if you're coming into the conversation as we need to have some kind of say. We, federal government or others, need to have some kind of say on what pathways of research you pursue at the university. What's your response going to be? No. Right? But then we say, I would like to give you the ability to make an awful lot of money off the thing that the ideas you've got. What does the university say? Here's our technology, and here's our technology transfer office. Like, let's do this. Like, let's build this, a startup engine in the university. So, a lot of times, I think the security conversation, to get back to the compliance mindset, is seen as this thing that's telling the researchers no. One thing that iGEM does is it says, yes, you want to do that work? Okay, here are the steps that we need to work through to understand that, like, how concerned we need to be and what we do, what we're going to be doing. And that's worked out with the teams, in the process of figuring this out. And that's seen, and then the teams, we can hold prizes as well. You say, okay, so this year there's going to be a prize for the team that develops the, the most interesting way of checking on whether their research is good for the world, for example. Like that creates a different incentive structure by turning the attention to safety, security, ethical, and other matters from this thing that you have to do in order to do your work to this source of inspiration for your work, which is what the commercialization process did as well. On the post-disaster issue, even if our institutions of governing can't really move before these events, there's an awful lot of work that's needed so that when these events happen, you don't just pull on thin air, right? You don't just pull the first policy think tank report that's on top of your desk. You have the networks of people that have been thinking through these things to say, okay, so what should be done? And that those networks of people, very importantly, include people, it's like, this is not going to be a good idea. This is all going to go wrong. And for them to be part of the conversation, instead of just a bunch of people that want to, ensure that their ideas pass, I guess is a way of putting it. So this post-disaster, I don't know if we can change, especially in the current political environment that we're in now. But what we can do is two things. One is be ready for when a disaster strikes with not just a set of ideas that have been dreamed up in academia, but those ideas being tied to the networks of the people who are doing the governing and who might actually have to be changed. This is the structure of CMIS, right? And two, in biology, there is this weird thought that we haven't had our Manhattan moment. Like, we haven't had our moment of reckoning of the biologist to say, this is not a good idea. Isn't that weird? We had an offensive biological weapons program in the country, and then we're like, it's not a good idea. But that seems to totally be absent from this conversation. We had, smallpox blankets. We had Tuskegee experiments. We've had many examples of the government crossing a line, and for that line to be understood as being crossed. And yet we're not weaving that into a narrative of that is who we are. We think that isn't who we are. And so we're going to govern as if that isn't who we are, and then we're going to be surprised when it turns out to be the case again.
So I have a two-part question. When it comes to emerging technologies, how can we mitigate for the weaponization of biological agents using emerging technologies like artificial intelligence as being resources for weaponizing the biological agents? And then the second part of that question is there a set protocol for, as research is developing, and let's say you stumble upon information as a biological agent being used for a weapon of, hey, we found something. Now this is a point where it's like a red line of either this is open source information, or this is going to be classified research?
So you're asking on the protocol that is in place for that kind of decision, or?
So that was the second part of the question. The first
Yeah.
part of the question is like, how do we mitigate for emerging technologies as weaponization tools for biotechnology?
Well, I think, so the first part of the question, I think, can be dealt with by saying, again, we don't know what we need to be concerned about. And so therefore, we should treat this as a space of research, as a space of experimentation. Are we doing that? There are lots of examples within the development of AI and other already in the last couple of years of stuff where it's this unanticipated or unintended consequence, but highly anticipatable if you had just asked a different set of people, like Amazon hiring only white males when it implements its AI algorithm. Shocking. Like, was anybody who was a woman or a person of color, like, would they have been able to see that was probably what was going to happen? I'm going to say yes. So getting those kinds of voices in the room and be part of the design process, I think, is what's needed here. Another issue, is that the ways of understanding what gets to count as a security concern differ in different technical areas. It's different for cyber than it is for bio. It's different from both of these very much than it is for nuclear or from conventional, goods. Understanding that difference is really important for when you're trying to think about the safety and security concerns, because you're going to understand where concerns originate differently. And therefore, you may not be looking for the convergence issues and with as much nuance as you might need to when you're thinking about something like the moving from digital to physical with biological constructs. Protocol for reporting. Right now, it's call your local FBI WMD coordinator.
Thanks. Yeah, definitely. As a biochemistry, systems biology, biotechnology, now PhD, but I never took a biosafety class. I don't think it's not until I did some policy work that I kind of took some modules just because they asked me some biosafety questions. But my question is kind of I can see how we can do this in terms of science sponsored and research sponsored by the government.
Yeah.
But now as these kind of technologies are developing and maturing, there's a lot of activity from the private space.
Yep.
And in their kind of developments and things that they're working on. What are the mechanisms to do this there, right? Because here we can say, hey, we're sponsoring your research. This is some things you need to be doing, but in the private sector, how does this type of stuff work?
Okay, so this is interesting. The private sector can move quickly, and private here I'm including and actually maybe predominantly thinking about foundations and philanthropies. Is that what you were thinking about, or were you thinking about companies?
Maybe both.
So with the government again, and the funding structures is a slow beast, right? It's slow to change. With companies, and particularly with philanthropies, they actually have been very active in these kinds of questions over the last decade, particularly in artificial intelligence, but it interfaces with biology. And what's the way that they're framing, right? So the idea is, maybe they could frame the issue in a more interesting way. I'm not going to go into, I can give a whole lecture on this, but it's basically the rise of the effective altruism movement, and the idea that we need to figure out how to do the most good with the money that we've got. But then if you frame the question in that way, what you're trying to do is figure out what is the most good, and that you can quantify that, and that you can, is it future lives lost? That then leads to your attention on catastrophic risks, existential risks. That then leads for, large funded policy programs in the US, the UK, and elsewhere to raise the specter of catastrophic and existential risks as a way of moving policy. But what is it for? Like, is the focus on this to try and just deal with these really big concerns through technical changes, or in order to understand and govern the kind of existential level concern, do we need a different level, a different type of governing, like a different way of understanding that the degree of uncertainty is so high, the ambiguity of and the ability to attribute these kinds of concerns could also be very high if we're not talking about like asteroids from space, but human-made issues. That we need institutions that can manage that uncertainty pretty well. Having an organization like an intelligence, community in the U.S. do that has its own shortcomings, right? Because the IC doesn't have that kind of public accountability that other spaces would do. They're great at managing uncertainty and handling uncertainty, right? But maybe not so much at incorporating a diverse set of viewpoints into what should be concerning, what should we do about it.
So we have time for one quick question and a quick question.
Maybe can we collect two, and I'll choose how to respond. It would be useful to get that. Can I get two for one?
Well, we only have 2 minutes.
Oh no. Okay. All right. Go for it.
From I do biomedical research, so kind of from that perspective. But I was really interested in when you were kind of talking about biosafety officers and the role that they have, especially like BSL levels. And I've done genetic editing, so a lot of the BSL levels and things like that have played a big role. But a lot of those biosafety officers don't know enough about our actual research topics to be able to, I think, identify some of these security concerns that you've brought up. And I just finished my PhD. This is not something that was ever brought up in my classes. Ethics were, but not a security concern. So what position would be in place to kind of help researchers find if you could wave a magic wand and put it in place, especially in academia, how would you put something in place to actually help researchers identify these types of concerns and change or adjust their research accordingly? So
what you're asking for here is a specific fix, right? I could offer a range of those depending on the specific organizational, political, contextual, technical environment that you're in. But I think a better kind of general answer would be to say that there is a range of attending to these types of concerns, and that that range, it can be embodied in a whole bunch of different types of people that exist within different points of an organizational context. So a biosafety officer could ask ideas in one way. A PI could have some training that could raise this kind of concern at an earlier stage. But then they might need to be connected with somebody at CMIS that has this kind of bread and butter of attending to the security and other kinds of concerns that then, might want to be pulling in particular government officials in various ways. I didn't get into the FBI's work with IGEM, but, the FBI was very forward-leaning with synthetic biology as it was getting developed. And they're like, I'm just here. If you want to have a conversation, come and chat. I give a keynote at the annual conference, and the biosafety officer wears jeans and kind of walks around amongst the students. But and they did this with all the DIY bio community when they were evolving as well, to say it's not just one person. it's this network effect, and organizationally that this kind of concern gets spread out and different people attend to it in different ways. You can map that very clearly if you think about the economics of research. It's just that we don't think about it. We don't think about doing that mapping with the security aspects of research.
Thank you. My experience has been that the secret to success is having somebody in the system who really gets what they need and realize that they can't do it alone. And the secret to failure is somebody who gets it and thinks that they can do it alone.
Yeah.
So, thank
yeah.
you.
Thank you very much.